Okay, guys, so starting off with the basic things that you need to know, guys, for those who are taking the May June exam, the first question in your paper form, most of the time you'll notice is going to be a motion time graph. Okay, it will either be a distance time graph here, right? Or it will either be a speed time graph here. Okay. Now pay attention. In terms of your graphs, it doesn't matter if it's a distance time graph, speed time graph, Hooke's law, force versus extension graph, Ohm's law, voltage versus current graph, right? You should always be looking at two main things only, right? The first thing is going to be your it's going to be your gradient, and the second thing will be your good, excellent, right? So why is it very important that you know all these things? I just saw a bar graph about speed and time. Don't worry about that, it's the same thing also, but let me explain this first. Why do I keep saying that the gradient and the area is important? Because the gradient and the area will always represent something. Mathematically, gradient, we know that it's change in y over change in x-axis. In this case here, this is your y-axis and this is your x-axis, right? Which is going to be your change in distance over your change in time. Then, naturally, we know for a fact that in the distance time graph, the gradient represents your speed law, right? Distance over time, right? So, in your exam, usually, if you're very lucky, they will just give you one straight line like this, okay? And they'll ask you to describe what's the motion of this thing here. If you look at it, you see that it's a constant gradient, then your answer will obviously be constant speed, right? But most of the time in your igcse's, I've noticed they will not give you such an easy question, okay? Instead, they'll give you curving graphs, either they curve down like this or they'll curve up like this, okay? By now, anyone don't know which one is increasing or decreasing gradient or not? This part here is increasing or decreasing gradient? Good. This part here is known as a decreasing gradient, which in other words is supposed to be decreasing speed, right? And this part here is obviously increasing gradient, so it is increasing speed. In your exam, maybe they'll structure it this way. They'll say that, okay, explain the motion of this part, explain the motion of this part, and explain the motion of this part. If it's just this part here, usually it will just be 1 mark. If it's this part here, maybe it will be 2 marks, and maybe this part will also be 2 marks. It's not on any page, it's just what I'm writing right now. There's no page here. This is what the hell. Are you not reading the group chat? That's me. Okay. Anyways, if they ask you to describe these two parts here, you must first mention that the speed is changing. Then you should say that the speed is either decreasing or increasing based on the gradient. Obviously, in this part here, you'll say that the speed is decreasing because the gradient is decreasing. And in this part here, you'll say that the speed is increasing because the gradient is increasing. Okay. What about area under the graph in the distance time graph? Will it represent anything? Will it? No, it will not. Why? Why will it not? Because if you think about it, right, if I want to find the area under this part here, this is a triangle, right? And if it's a triangle, it will be half times x times y, right? Which in this case, it will be half times distance times time. Distance times time is not speed, bro. Distance over time is speed, bro. Right? So, what? Speed is distance over time, bro, right? So from here, distance times time, it represents nothing. So in what I want to emphasize is not all the areas represent something, and not all, but all the gradients definitely represent something, yeah. Okay. So in this case here, you're supposed to say that area doesn't represent anything, so don't be baited by the question. It's not supposed to mean anything. But in a speed time graph, it will be a totally different scenario, right? In this case here, let's say for example, once again, the gradient represents acceleration. Good, right? Why do I know this? Because acceleration's formula is v minus u over t, right? Which is change in velocity, change in velocity over change in time, right? The gradient is once again the y-axis over the x-axis, right? So I know for a fact that in the speed time graph, the gradient represents the acceleration, but the area here will this time represent the Yes, this time it will represent the distance here. Okay, so if you're asked to find how far this car traveled, you find the area under here, which I also notice a lot of students are, especially when they panic, they'll tell me that, okay, the area here is 10 times 3. What's wrong? Is it 10 times 3? No. What else is missing? Yes, it's half, because this is a damn triangle, right? This is a damn triangle, right? Don't panic, guys, in your exam. Okay, make sure you look at the area under the graph and you identify what pattern it is, right? Then actually same thing also from here. If let's say they have a graph that looks something like this, or a graph that looks something like this here, right? It is increasing gradient or decreasing gradient, right? Which in other words is going to be increasing acceleration or decreasing acceleration. I do want to highlight this part here, guys, the decreasing acceleration part. Is decreasing acceleration the same as deceleration? No. What does decreasing acceleration mean? Good, it's less acceleration. The speed is still increasing, guys, right? Just that the increase in speed is slowing down. For example, if I were to put it numerically, maybe it will be 10 meters per second, jump to 20 meters per second, jump to 25 meters per second, jump to 26 meters per second. This is what it means by decreasing acceleration. It is not the same as deceleration. Don't write deceleration on Tuesday, guys. I mean Wednesday, guys. Don't write deceleration on Wednesday. Okay, so this is the one thing I wanted to highlight. Then after that, I also want to highlight one more thing, guys. In terms of the Hooke's law's graph, what's the definition of Hooke's law again? Anyone can tell me what's the definition of Hooke's law again?
The letter of expansion is directly proportional to the force within the limit of proportion.
Very, very good. Okay, Hooke's law's graph looks something like this. Okay, it will be a force versus extension graph. Yeah. And then it will be one straight line first. Then after that, it will start to bend like this, right? Now, if you can remember this graph, you can literally bullshit your way through the whole thing, guys. You're supposed to say something like, Hooke's law states that the force is directly proportional to the extension, provided that the elastic limit or limit of proportionality or whatever you call it, right, is not exceeded, right? In other words, this part here obeys Hooke's law. This part here doesn't obey Hooke's law, okay? Now, in your exam, in terms of this Hooke's law, you better read the axis properly, because I've seen at least 2 variations of this. The first one will be something like this. They will give an extension versus F here. Then my students, bandai, they will draw like this also, right? Which is obviously wrong, because it's an extension versus force graph. So if it's an extension versus force graph, you draw it like this instead, right? Sometimes I have also noticed in your past year papers that they don't give the force versus extension. They give a force versus length graph. And you are supposed to find the extension. Originally, they will say that the length of the spring is this amount already. Let's say it's 10 already, right? Then it extends by this amount. Then after that, only you start bending like this, right? If they ask you to find the extension, you're supposed to take the second value minus, let's not make it 20. Let's say it's 15. You're supposed to take the second value minus the first value, only then you can find the extension, guys. So in conclusion, on Wednesday, read the damn graph before you start jumping into conclusion, guys. Very, very important. What's the formula for Hooke's law again? Why is there another me? I don't know. Are you having split personality already right now? Oh, who's the other Jen? Who's Jen? Who's Jen?
Eugene?
Oh,
Eugene.
is that Eugene? Ooh, maybe it's Eugene. Yeah, most likely it's Eugene. Yes, it's Eugene here. Okay. But anyways, Yeah, just be very careful. I'll read the diagram. What's the Ohm's law formula again? Good. F equals to kx. Now, in terms of your F equals to kx, your k is obviously F over x, right? I've seen different units from here as well. They will definitely be force, right, which is in newtons. And this could be either in meters or it could either be in cm, guys. It could either be in Newton or meters or it will be in cm. So based on what they write here, you better write the units properly, guys. Don't fixate that there is a fixed unit. Okay, read the units properly. If here they say meters, then you write meters, or if here they write cm, then you write cm. Just be very careful, all these small little things. You'll lose your marks, by the way. It sounds dumb, right? And you, like, everyone here will hear the story and say that, nah, I'm not that guy, right? But I tell you, 1 year I had, K is the spring constant, bro. 1 year I had one of a very smart student draw the voltmeter in series and an ammeter in parallel because she was panicking and so on. So just make sure you tell yourself, read the instructions properly, then you'll be fine. Okay. Then after this, what else do you need to know? After the spring constant, moments, okay? Moments, which is for some reason one of the most dreaded topic for everyone here, guys. What's the formula for moments again? Very good. Moment is known as force multiplied by distance to the pivot mark, right? Now, I have, for some godforsaken reason, a lot of students telling me that the pivot will always be in the middle one, even though the question will give you something else, right? They'll tell me that the pivot is in the middle. Guys, please make sure you get that idea out of your ass, right? And understand that the pivot can be literally anywhere, guys. And I also want to highlight one thing is that, let's say, for example, the force X is F1, okay? And this is F2, okay? They'll tell me that this distance here, let's say is 1 meter, and here to here is, let's say, 2 meters. If let's say I say that this thing is in equilibrium, then obviously we have to start using the moments in equilibrium formula, right? What does the moments in equilibrium formula state again? Okay, there is no resultant moments. Then the formula will be total anti-clockwise moment is equal to the total clockwise moment, right? In this case here, because there are only 2 forces, then what happens is you just F1 D1 equals to F2 D2, right? My question is, how much is F1 and how much is D1 and how much is D2? Melanie, how much is D1 and how much is D2? It's written here, is it? So D1 is this, and then D2 is this, is it? Very good. Exactly how you lose your marks in the exam. What's wrong, Raquel? What's wrong? Don't tell me you don't know. Anyone tell me what's wrong?
For D2, it's 1 plus 2.
Very good. Excellent. That's the right answer. Your D2 is always distance to the pivot, right? I just said distance to the pivot, right? So a lot of students, in fact, I've done this multiple times also. Sometimes I jump the gun and I see this number, I'll straight away write this as D2. But you should always remember that the distance is always to the pivot. And thus, it should be 3 meters instead, guys. Very important. Be very careful, especially when it comes to moment. Like, I can foresee a lot of students lose marks because of this. Okay. Then what else? What else is important? Okay, in terms of momentum. Okay. What's the formula for momentum again? Very good. Momentum is equals to mass times velocity. What about impulse? What are the 2 formulas for impulse again? Okay, very good. Wow, very good. Excellent. Are you going for the May June exam also? Okay, it'll be nice. Okay. Make sure you remember this. And if you ever forget the impulse formulas, you can derive it from the F equals to ma formula. Remember? Right. How do we do it again? What's A will be? Good. And I substitute this in, it will be F equals to mv minus u over t. Substitute this again, it will be mv minus mu over t. And finally, ft will be equals to mv minus mu. Right. Right. Please make sure you know how to derive this. In terms of principle of conservation of momentum, guys, what's the formula again? What's the formula?
Oh.
I don't know. I'm in the October, November exam. I don't know. What's the formula?
The half mv square equals to mv1.
No, principle of conservation of momentum. What's the formula?
The three.
Yes. No, sorry. I mean the yes to the Henry's. Sorry.
M1U1 plus M2U2 equals M1V1 plus M2V2.
Very good. It's M1U1 plus M2U2 is equal to M1V1 plus M2V2. Right. From here, I want to highlight one specific scenario, which is the inelastic collision scenario. Okay. Let's just say today I have one ball A, which has a mass of 3 kg moving at a speed of 4 meters per second, knocks into ball B, which is 5 kg. And I say that, which is initially 0 meters per second. And I say that after they collide, they move inelastically together. What does that mean? Good, they will stick together. And when they stick together, if I were to apply the formula here, right? What will change to the formula if they stick together? Okay, the mass is together and the speed is the same also, guys. Now, I want to highlight this. A lot of students, what they do is they'll start substituting this in. They'll say that, okay, M1, which is 3 kg, the speed, which is 4 plus 5 multiplied by 0 is equals to first one, which is still 3. Then they're like, hey, V1 is what? Then this one is 5. And then they'll say like, hey, what is V2? Now, guys, if you are stuck in this situation here, know for a fact that one equation cannot have two unknowns. You should then ask yourself, hey, this is inelastic collision, right? And if it is inelastic collision, it means to say there will be no longer V1 or V2, right? Because both these things are moving together, right? So from here, you should eliminate the 1, eliminate the 2. And from here, it will become a single unknown equation already, right?
8V.
Sorry?
8V.
Yeah, it will be 8V. So it'll be like, you ultimately end up with 12 is equals to 8V, and ultimately your V will be 1.5. Very good. Those that are not going for the major exam. But those that are going for the major exam, make sure you know, okay, this was the only thing I wanted to highlight for the momentum one. And then after that, the rest of it is just literally apply the formula and understand the concept only. What else was important? The next one was going to be the energy chapter, okay, which is the principle of conservation of energy. This is the one where it's the half mv squared equals to mg h1. Now, I've said this before, in terms of your energy chapter, they love to mix the energies all around. Especially, they'll say something like, okay, right now, the kinetic energy, right, is, let's just say 1000 joules. Okay, and then somewhere along the question, they'll say that the mass of the object is like 10 kg, and they'll ask you to find the speed of the object if it's rising. Let's say they say that this bullet here initially has an initial kinetic energy of 1000 joules flying upwards, and they want you to find how high this is, how high the bullet will fly. In this scenario here, obviously, what energy is being converted into what energy? What energy is being converted into what energy here? I want to find the height where the bullet flies.
Potential.
What to potential?
Kinetic.
Yes, it's obviously kinetic energy into potential energy, right? Which in this case here will obviously be 1000 joules equals to mgh, right? From here, literally substitute the formula in only. Yes. No? Okay. Everyone just substitute the formula in. If you're shit at algebra, then it's GG already until this point. But hopefully you're not shit at algebra. Hopefully you know what's going on, then you know what to do. Okay. Now the reason why I want to highlight this is because it will not only be subjected to potential to kinetic. It could be heat energy into kinetic energy. It could be work done into potential energy. It could be even electrical energy into kinetic energy, or so on and so on and so on. I just want you to know that energies, potential could be converted into kinetic, which could be converted into heat, which could be converted into electrical energy, which is VIT. Guys, all these energies will ultimately play a role. So you need to identify what information is given to you, and then you need to know what to write. Okay, what formula to write on. Very important. Must know this. Okay. Then what else was important? How do I convert degrees Celsius into Kelvins again? Good, it is 273. Plus or minus 273? Plus 273. Right, so let's say, for example, this is, by the way, this is the first year they introduced this. So it is very likely to come up in your exam. You must know how to convert degrees Celsius into Kelvin and Kelvin back into degrees Celsius. 0 degrees Celsius is equivalent to 273 Kelvin. 100 degrees Celsius is equivalent to 373 Kelvin, and so on and so on. You better have this number in your head. I expect it to come up in this year. Like 100% certain it will come out. It's just a matter of whether it will come out in your paper 4 or it will come out in your paper 2 only. You must know. Oh, to convert kinetic energy to heat, we use Ke equals to mc theta. Yeah, yes, you're right, Janet. It's going to be half mv squared equals to mc theta. Yeah. Okay. And then once we have that, how does evaporation occur again, guys? How does evaporation? If today I ask you to explain evaporation in terms of the molecules, how do I explain it? 3-mark question.
It happens at any temperature.
Okay, evaporation happens at any temperature, and then
The molecules gather energy from the surrounding event.
okay, I want to highlight this also. A lot of students, they always tell me that evaporation occurs when the energy is gathered from the surrounding. This is only partially true. Okay, why do I say it's partially true? Because let's say, for example, if it's a hot day, you have a cup of water, obviously the heat is being absorbed from the surrounding and everything, right? But what if it's a cold day? What if today the temperature is like 2 degrees Celsius outside? Will the water still evaporate? It will. But I know for a fact that the tap water that comes out maybe is like, let's say it's cold, but it won't be that cold, right? It'll be 10 degrees Celsius. It's definitely not absorbing energy from the environment anymore. Where is the energy absorbed from? Where is the energy absorbed from? I was like, shit. No, there's no radiation involved. Where? Kinetic means what kinetic? What kinetic? Where is the energy coming from? What kinetic? Where? Shit, am I missing out any students? I have so many people messaging them. Don't press.
Evaporation happens at the surface.
Yes, I know, but where does the energy come from?
The molecules escape from the surface of the liquid.
Yes, I know it gets escaped from the surface, but where do the energies come from? In order for the molecules of the surface to escape, they must absorb energy from somewhere. Earth's core.
No, from hot air.
Okay, guys, no more guessing already. I'm getting cancer already. Okay, guys, pay attention to this. I have a huge hunch this year that it will come out. By the way, it's either May, June, or October, November only. We all know that the surface molecules are the ones that go through evaporation, right? Let me tell you, okay, the evaporation occurs because they absorb energy from the molecules below it. Guys, not from the damn Earth's core, not from the kinetic energy, not from some funny answer which my brain already filtered already. No, guys, okay, no. It comes from the energy below it. Okay, don't worry. That's why it can happen at any temperature, right? A lot of students, they always think that it will come from the surrounding. It's true. The surrounding does provide energy, but what if the situation change? Like, for example, 2 degrees Celsius, then it will be a totally different story, right? But I know for a fact that evaporation will still occur because energy is absorbed from the molecules below it. This is the keyword. Energy is absorbed from the molecules below it. Okay, so from here, your standard situation number one, definitely you must say the surface molecules absorb the energy from the molecules below, right? And once the surface molecules absorb enough energy, they'll break the bonds, guys. They'll break the bonds, right? And change state, they'll break the bonds here and change state, escaping to the surrounding as gas, That's why these that escape, their energy is relatively higher, right? The more energetic molecules will always escape to the surrounding, leaving behind these ones that have more or less energy. It'll have less energy, right? That's why the temperature drops after evaporation. You have to write these few things, guys. For sure, you have to write that it comes from the surface, the energy comes from the molecules below it, they break the bonds. The more energetic molecule escape from the gas, that's why the less energetic molecules are left behind. These are the few keywords that you must write out. If they ask about evaporation, in one way or another, it will be 3 marks on if they ask you to explain. Yes, correct. They absorb energy from the molecules below it. Yes, correct. Okay, everyone, this is very important, yeah. You must know. Okay, what about Brownian motion? What's Brownian motion?
The random motion of particles.
Okay, if I would, sorry, before we talk about Brownian motion, what are the 3 key factors that affect the rate of evaporation? Temperature is one of them. Come on. Surface area is one of them.
Wind.
Humidity, don't write wind, guys. Even though the humidity is affected by the wind condition, but usually the standard answer is supposed to be humidity. Humidity is basically how wet the environment is. Okay, like for example, Malaysia is a damn humid country. That's why we always feel very sticky after we sweat, right? But if you ever go to Japan, Australia, or all the drier countries, right, as soon as you finish sweating, your body feels clean again. That's why the Quailos, they don't like to shower for months and months and months.
Oh.
No, not in Malaysia, not in Malaysia, bro. I'm talking about the overseas one, guys. In fact, right, I had one friend in uni. When he went to study overseas, right, he dared to tell me 1 month he don't need shower. Right. And from that day onwards, we called him a very mean nickname, which has some vulgarities inside also. No, sorry. After class, you ask me. Now it's recorded session. It's like, why this teacher? Okay. All right, so that's that. Okay. Then shit, what was I talking about? Oh, we were talking about Brownian motion. In terms of Brownian motion, name me the two key characteristics that are always in the mark scheme one. Okay, random zigzag motion. And then
By tiny invisible dust particles.
no. In terms of the characteristics, is random speeds. Okay. So from here, you're supposed to always write, if they ask you to explain what Brownian motion is, you must write these two things down. Random zigzag motion and random speeds of the air particles due to bombardment of other smoke particles or the air particles. Very important. Okay. Now, I want to ask one more specific question, which I also have a huge hunch is going to come out. Okay, let's say, for example, today, right, I have some air molecules inside a closed container here. Water molecules smaller than hit the pollen grains, right? Yeah, yes, correct. Okay, this is also something I want to ask guys. If let's say, right, we know for a fact that in a closed container, the pressure is going to increase with temperature, right? Explain to me in terms of momentum how the pressure increases. In terms of momentum of the air molecules, how will the pressure inside a closed container increase? The keyword is momentum. Wow. Yes.
When the container is smaller, the particles collide with the walls more often, and then the change in momentum more.
Damn, son, are you sure you need to be in this class? Damn, son. That's correct. That's correct. Which will always come out in the exam, guys. Now we know for a fact that the reason why the pressure inside a closed container increases is because the air molecules collide against the walls, right? If they don't ask about momentum, usually the formula is pressure equals to force over area, right? We know for a fact that as the air molecules collide against the walls more frequently, this increases the force per unit area against the walls of the container and ultimately is going to increase the pressure. But if we are asked in terms of momentum, which I say I have a huge hunch coming into this exam, you're supposed to add one more layer to the formula, which is F equals to mv minus mu over T. Right, from here, if you can remember these two formulas, once again, you can bullshit your way through already, right? You're supposed to say that as the air molecules collide against the walls of the container, this increased rate of change in momentum increases the force produced per unit area, ultimately increasing the pressure. I repeat, pay attention. You're supposed to literally bullshit your way through the whole formula. You say that as the air molecules collide against the walls, right? This increased rate of change in momentum increases the force per unit area against the walls of the container, ultimately increasing the pressure, guys. You're just supposed to explain it in terms of the formula only. If they don't ask about momentum, you can just say this here. But if they ask about momentum, then you must include this formula here. Do you all understand what I'm talking about? This is very important. Okay. I have a huge hunch that it will come out this year. But then again, I could be right, I could be wrong, right? But if I'm right, then I can start to raise the ranks to somewhat of possibility. Okay, but anyways, this is something that you must know, guys. It comes up very, very often in the exam. Okay. And what else do you need to know? How about air molecules that are becoming smaller, guys? If today I have a closed container, right? And then let's say this is a balloon, and I compress it even smaller here. How do I explain the rise in pressure? How do I explain the rise in pressure as the volume decreases? In terms of the air molecules also. Yeah, less area. Okay, that's not exactly wrong. Somehow. Less area, same volume. How does that work? How? In terms of the air molecules, why when I compress a balloon, it feels that the pressure is getting greater inside the balloon?
Because there's the same amount of gas that is small and smaller container.
You got them right. Yes, guys, most of you guys know of the answer also, guys. Let's imagine today, we have like 9 air molecules in both of these scenarios here. When I compress it, these nine air molecules will occupy a much smaller space, right? Oh yeah, sure, I'll send the recording. When these air molecules occupy a much smaller space, what happens is that the air molecules will collide against the walls more frequently, right? Once again, guys, the keyword is collision against the walls of the container. A lot of students, they also like to tell me that the air molecules will collide against each other more often, which generates nothing, guys. The keyword is always going to be collision against the walls of the container. It's a keyword, okay? Collision against the walls of the container will obviously increase the force produced per unit area. Then after that, you're supposed to explain this again. So in this one here, you're supposed to say a few things only. There's a smaller space, right? There's an increased rate of collision. And then ultimately, once again, the force per unit area increases. And then the pressure increases. Guys, these are the few things you must know. Okay. Mình tạm mang thôi. You understand Cantonese? Okay, very good. Okay, this is the thing that you should know. Then after that, what do you need to know? Specific capacity. What's the formula? What's the formula for specific capacity? Did you say it again? Yeah, here we will MC theta. How do I define specific capacity again? What's the definition? What do we do? What do we do? You're not even listening to the
Temperature required to increase the
not the temperature required.
The energy required to increase 1 kilogram of substance by 1 degree Celsius.
Wow, it feels like he's the one going for the main unit exam, Guys, if you're asked to define what a specific capacity is, which always comes out once again, you're supposed to rearrange the formula, and once again, you're supposed to. Hey, you kingdom, bro. You have to say like that, you keep pressing my buttons for what? You're supposed to say specific heat capacity. What formula is this? GG already, now. You're supposed to say a specific capacity is the amount of heat energy needed to change 1 kg of a substance by 1 degree Celsius, or however you want to word it, okay? But you must include all these things here. I repeat, specific heat capacity is the amount of heat energy required to change 1 kg of a substance by 1 degree Celsius. Very important, always comes out. Okay. Oh, one more thing I want to mention on top of the general physics chapters before we move into the heat. What's the 2 conditions for anything to be in equilibrium again? I say always comes out in the exam one. 2 conditions for any object to be in equilibrium. Very good. For anything to be in equilibrium, right, there must be no resultant moment and no resultant forces, guys. This question also always comes out in the exam. Yes. Right, it's a standard answer. I think you have seen these questions before, right? Okay, yes. Yes. Okay. What else is needed? One more thing I want to highlight, guys. When you're doing the Q equals to MC, guys, when you're doing the Q equals to MC data, I want to highlight that be very careful with this part here, the change in temperature. Because a lot of times, right, the question will say like something blah 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 blah. The thing starts off at 22 degrees Celsius. Then after that it will be blah 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 blah. What happens after it reaches the boiling point? And then naturally, right, this is what happens to all the students, by the way. They'll say that, oh, usually students, right, they are very, very sensitive to the numbers one. But they'll never see the words here one. This data is supposed to be change in temperature. If boiling point is 100 degrees Celsius, the change in temperature should have been 78 degrees Celsius. Be very careful because this is quite a standard way the igcse will scam you guys from your marks. Be very careful when you're doing the question. You understand? Okay. And then one more thing I want to ask, what does MS mean? No slash one. But I say that it took 10 ms. Good. It is millisecond. Yes, very good. It is millisecond here. Right, it's supposed to be 10 times 10 to the power of -3 seconds. Be very careful with the units. You will lose your marks. Be very, very careful with your units. Okay, what else do you need to know? I also don't know what you need to know. Let me think for a while. Huh?
Oh, I feel myself. So the center of mass.
Okay. Center of mass thing. Okay. So in terms of the center of mass, we know for a fact that all objects have a center of mass literally at the center, right? For any regular shape objects. But irregular shape objects will have different center of masses, right? Let's say, for example, maybe this thing will have a center of mass here for some reason. Okay, but it doesn't matter why. Okay. In your exam, if they ask you about center of mass, right? Number one, they'll either ask you to define what the center of mass is, which you are going to say it is the point where all mass act upon, right? And number two, if they ask about center of mass, usually they'll pair it with the pivot question, okay? Which will be something like this. They'll either say that, okay, right now I have a really long bar, and then I have like some pivot here, and then I say that this thing is, let's say like it's 100 cm. Okay, and then I say that the mass of this object is 10 kg. If let's say here to here is 20 cm, where is the weight acting on? And how much is it?
30 cm from the middle.
Okay, it will be 30 cm from the pivot to the right. Right, this will be the weight. But how much will the weight be? 10 kg. Weight is in newtons, right? So how do I convert mass into weight? Good. W equals to mg. Okay. Now I want to highlight this also. Your year is the first year they changed the gravity. All your past year papers that you're doing all until this point is always going to be 10. Okay. Yes, but your year is going to be 9.8. Yes, very good. Everyone knows this. If you lose marks to this, then you deserve to die, right? Hey, I've said this multiple times already. Okay, 9.8. Then from here, you just change law, 98 Newton's law, right? Then this thing here is obviously going to generate a clockwise or anti-clockwise moment. Which one? The 20 cm. Which one? Is this going to generate a clockwise or anti-clockwise moment? It will generate a clockwise moment because it is with reference to the pivot, guys. It is with reference to the pivot. Okay, what about this one here? It's on the right side also. Will it also be clockwise? No, it will be.頂你個肺，有考試了。Okay, all right. Be very careful. Oh, I also want to highlight one thing. Which occasionally comes out if you're unlucky. You'll see this in your year also, guys. You'll say that I have this thing here. Okay, And then I have one string that hangs in this side and one string that hangs on this side here. Okay? And the only information they give you is that, wow. Here to here, for ease of calculation is 10 meters. And the weight is, let's say the center of mass is somewhere here. Let's say it's 100 newtons for ease of calculation once again. And then let's say here to here is 4 meters. Wow, that's really distributional. Let's say it's 3. Okay, so they'll say that this is tension 1, this is tension 2. This one also, students always they find it very hard to do. How much is tension 1? How to do? How much? 700? No, tension 1 more. So like there's like a log here, right? And then it's hang by 2 strings. How you know it's 300?
Because from you E2 as bigger, so
okay. Then that's the correct first step, but that's not the final answer. Is this upwards equals to, yes, this one will be equals to upward force equals to downward force. No, I don't think it's going to be 70 newtons. At least I don't think so. But guys, if they ask you this on Wednesday, guys, I want you to know that pay attention, this is very important. If I have something being held together by two springs or strings or whatever that is, right? And you're asked to find the tension of either side, you must always eliminate one unknown away. In this scenario here, by right, I know for a fact that since these 2 strings balance the 100 newtons, I know for a fact that T1 plus T2 is equals to 100 newtons, right? Right. But the problem is right now, this one equation has 2 unknowns. So this is actually a step for later on. Instead, what I should do first is I must use moments here to calculate the question, which is what he said is correct lah. If I want to find T1, I have to place a pivot at this specific point here. Okay, if I place a pivot at this specific point, then the whole diagram, if I simplify it, right, it will be something like this already. Okay, now this question comes out on like rarely, but whenever it comes out, a lot of students they cannot do it. If you can do this question while other students cannot do this, you will definitely be pushed upward into the threshold and once again make it easier to score an A. Okay, so once I have this ready, then this is basically moments in equilibrium once again, right? Which will state that the anti-clockwise moment equals to clockwise moment, right? So I don't know, I gotta calculate it. So it will be like 100 multiplied by 3 is equals to T1 multiplied by 10, right? Yeah, it will be 30. It will be 30 newtons. The T1 will be equals to 30 newtons. Once I have this 30 newtons here, I know for a fact that this guy here is supporting the rest of the 70 newtons. Anyone don't understand this? This is very important. Like, if you know how to do this, you'll be definitely better than the rest of them already. Anyone don't understand this? They say I got teachers. Okay, everyone. Okay, your first step was correct already. Oh, can I explain how you got the second diagram? Oh, I just simplify the forces only. Okay, why? Because you see, when I have any pivot acting on, any force acting on a pivot, right? Usually we straight away ignore it. Okay, meaning to say the force is gone already, you ignore it. So right now I look at only this component only. I look at this component here, and I look at this component here. You get what I mean now? Then from here is basically just simplify it into this scenario only. Okay. Okay, good. Yeah, this one you must know. If you can do this, then you'll be better than at least 50% of the people, if not 70. Okay, and what else do you need to know? Conduction, convection, and radiation, right? If they ask about conduction, guys, you have to know that conduction occurs because of, in terms of molecules, how does it occur? How does conduction occur in terms of the molecules? If today I have a heat source here, and then there's molecules here. Good. The heat source will heat up these molecules. They will gain energy and then start vibrating, passing on energy to the other molecule, pass energy. Okay? If this thing is a metal, then you must mention that they pass energy through the free moving electrons. The free moving electrons, guys. Right? But if the question says that it is not a metal, then you cannot write free moving electrons, because only conductors have free moving electrons. Only conductors have free moving electrons. Plastic lah, wood lah, glass lah, all those, right? The molecules will still vibrate, but you cannot write the free moving electrons. Very important. But if it's metal, you must write the free moving electrons. Usually it will be included in the mark scheme. Okay. How about convection? How do I explain convection in terms of the density? Okay, why does the heat rise? If today I have a cup, if I have like a pot here and now I'm heating it up, explain in terms of the hot molecule and the cold molecule, the density, what happens? Huh? Good, due to? Why does the density? Sorry? Further apart. Okay, that's acceptable. But the easier way to say this is say just understanding density. Density's formula is what again?
Mass over.
Good, is mass over volume. Right. So today, if this thing here is closer to the heat source, right? This let's just focus on one specific water molecule. This water molecule is closer to the heat source, right? So it's being heated and heat expands, right? Heat expands means to say the volume increases, right? The volume increases, but the mass stays the same here. If the volume increases and the mass stays the same, then the density decreases. That's why it will rise towards the top. This colder molecule here, the volume didn't decrease, but it is relatively more denser. Yeah. It's relatively more denser, that's why the molecules will sink to the bottom. This is the reason why heat expands, heat causes the air molecules to rise up and the cold molecules to come down. What? That's why your aircon is always on top, guys. Imagine if everyone was retarded, right, and then they set the air cons on your feet level, you know what will happen? Your head will be hot and your feet will be cold consistently because the cold molecules keeps going down, right? It's the same thing like why your refrigerator, if you ever open it, you see that the cold condensed air kind of comes downwards, right? Yeah, it freezes at the bottom first because the cold part is always at the bottom. It's the same reason why no one will ever install a heater on top. If you ever go to like the winter countries, the heaters will usually be the ground level because they want the heat to circulate to the top. Then the whole room is more balanced. Okay.
Why freezer on top then?
Freezer on top so that the cold molecules can come to the bottom. I mean, the freezer doesn't have to be at the top. I've seen refrigerators with freezers at the bottom also. But the thing that pumps out the cold air, I don't know what's that thing called, the freezer compartment that is responsible for the cold air, right? It will usually be on top also. So that when it pumps out the cold air, all the cold molecules will sink to the bottom. Go home and look at your fridge.
Both of them.
Huh? What do you mean?
Both of my fridge freezer also talking.
What the two fridge one have at home? 你家有几多个人？2个 freezer
六个
啊
，6个
，6个人好吗？你是最大还是最小？
最大，
Oh, so I'll be seeing your brothers, is it?
7
Okay. Okay, guys, understand this part, right? Okay, then in your exam on Tuesday, on Wednesday, if you see these keywords, black lah, white lah, shiny lah, dull lah, what are they trying to test you on? Yes, very good. For sure, they're asking you on radiation. And in terms of radiation, black and white, what's their characteristics? Black is a good absorber, good emitter or radiator, and bad what? Reflector of heat. So it's always going to be absorber, emitter, and also reflector, guys. Right. Black is good absorber, good emitter, bad reflectors. White or silver or whatever is bad, and good. The exact opposite. Okay? The exact opposite. You must know this also, guys. So if they ask about these, if you see this word, you better have all these things here in your head. And you must write everything down. Right. And obviously you're going to say that the temperature increases more for the black one. It's quite standard on the question. I'm sure you guys know this by now. And if you don't, then it's you. Okay. And then what else? What else do you need to know? Okay, in terms of the water waves, reflection, refraction, and diffraction. What is the one thing that doesn't change? What one characteristic never ever changes? Good. Frequency never ever changes, guys. It doesn't matter if it's reflection, refraction, or diffraction, which always comes out in your paper 4-1. You must know that reflection, refraction, or diffraction never ever changes. If they ask you to draw, like the only thing I can think about is, right, if they ask you to draw in terms of the water wave, the reflection of water wave is very straightforward. Let's say I have waves coming in this direction here. All you need to do is draw the direction of the wave coming in from the wave fronts. You can even draw the normal and then measure this, and then you could draw this. Okay. Make sure when reflection happens, the wavelength doesn't change, the frequency doesn't change, and also the speed doesn't change, which is with accordance to V equals to F lambda formula. Okay, meaning to say when you draw, if let's say here is, let's say 5 cm, here better be 5 cm also. Okay, it is a criteria. When we draw this, do we need to measure angle as well? Depends on the question. If they ask you to draw accurately, then you measure the angle. If they ask you to sketch, then by eye level, it should be fine already. Okay. Then what about refraction of water waves? Hey, in order to understand refraction of water waves, I want to ask first, is deep region faster or shallow region faster? Deep region, how do you remember it? For those who cannot remember, guys, remember the story when you're at the beach, guys. Imagine today you have finished your IGs already and you go to the surfing beach. If you go to the surfing beach, you'll always see that the waves are super damn high, far away, and then as they come closer to the shore, it becomes lower, right? This is because this deep region here, the speed is higher, the shallow region, the speed is slower. Okay, this is a must know. It's a must know. Okay, and your exam usually how they'll ask you is they'll give you 2 damn boxes, right? They'll say that, okay, right now this is deep and shallow region, and then this is like shallow and deep region here. Then they'll say that, okay, right now I have wave fronts coming in this direction, and I have wave fronts coming in this direction also. Yeah. Okay, whatever. Okay, then I ask you to finish drawing the diffraction. Sorry, the refraction of the waves. This one here, will it lean forward or lag behind? Okay, let me change my question again for since both of you guys didn't join before. Originally, the wave was supposed to be one straight line like this, right? Right. After it goes from deep region to shallow region, will the wave bend to the left or will the wave bend towards the right? That is your left, is it? Yes, it will bend towards your left. Why? Because here, this velocity is, sorry, from here to here, guys, from deep region to shallow region, the velocity decreases, right? And when the velocity decreases, what happens is it will slow down the wave and it will bend towards this direction here, right? Which means to say the wave is lagging behind. Once you have these two, make sure that they are parallel, then you just draw the rest of them parallel only. Okay? And without you adjusting, automatically the wavelength already decreased. Automatically the wavelength already decreased. Okay? Right? Oh, this one here. Well, will it bend towards left or right?
Right.
Yeah, it will bend towards the right because the speed is faster right now. Once you draw the first few, then you just draw the rest of it. And you know that it will go somewhere like this. Okay, everyone. Very important. What about diffraction? What about diffraction, guys? What's the condition for diffraction to occur more? Good. When the gap is smaller than the wavelength, or if the wavelength in general is high. When the wavelength is high in general, the diffraction occurs the most. For example, if let's say they ask you to draw, right, they'll usually give you this. Yeah. They'll give you this stupid diagram, right? Which I'm sure you've seen 1,000 times by now, right? I want you to know that you should start from the gap here. And if you know that the diffraction occurs a lot, you draw very nice Wi-Fi signals. If let's say in the opposite scenario where the gap is too big, you know the diffraction occurs less, right? Sorry? Yeah, it's slightly retarded Wi-Fi signals, right? And there's something like this. Oh, I do want to highlight one thing also. When you draw diffraction, the wavelength doesn't change also. So, however much the wavelength was originally here, the wavelength here should be the same also. And the condition is it must always start at the gaps here, guys. It should always start at the gaps here. Very, very important. You must know how to draw this. Okay, one last drawing before we end the day, and then we'll continue this on Tuesday. I'm sorry, but no need. But like slightly away. Okay, one last drawing before we end the day, and then we continue this on Tuesday, guys. Tuesday is going to be 1.5 hours, guys. I'm going to try to cover as much. It doesn't have to touch the edge. Okay, if let's say for example today I have a puddle of water here, right? And I say that my goldfish is here. Okay, and then I say that my eye is here. They ask you to draw 2 light rays to locate where the image is. How do we draw this? Where do we start? Locate the image of the goldfish. Obviously, refraction is going to occur here, guys. Right? So how do I draw the light rays? 2 light rays. You draw. Show me. Show me. 你不要跟我讲你不会这个always comes on an exam one Hey guys, pay attention very important I have a huge hunch that this will come out also First and foremost, if you draw it the normal way, you're supposed to draw light rays that goes out from here. Let's say starting from this point You draw light rays, you draw like a V shape here first, right? You draw V and then V here. Then after that, you draw the light rays that goes from the eye here, right? Then, I mean, my drawing is a bit ugly but by right, you're supposed to have like straight lines here, here, and then this was where the goldfish is. You can see that if I do it the right way, it's very hard to draw, right? So I always tell you guys to cheat, right? So what you do, you know for a fact that refraction by now, you know that the image is going to be more shallow than how it really is, right? Everyone knows this, right? Like for example, you stand on top of swimming pool, hey, this is not so deep, then you jump down and it feels like it's much deeper than it is, right? Sorry? Hey, what? Yeah, but you don't drown lah, right? If not, you won't be here today, right? So you know for a fact that the image is more shallow than it is, right? So what you do is you straight away cheat, right? You know for a fact that the fish should be somewhere around here lah, right? The fish should be somewhere around here. Then with this information, all you need to do is you need to draw the V shape to the fish only, right? Then you draw like something like this. You draw something like this. Right, but make sure it's dotted line here, by the way, like dot, because this is virtual light, right? Then after that, once you have that, you draw, you just continue from here. Then bam, it's a much more nicer drawing than if you draw it the normal way. So you always cheat by knowing that you better have this damn image in your head by now. Then you can cheat. You can reverse engineer the lines and then you can draw a nice one. Okay, because ultimately guys, ultimately you're supposed to have a V here guys. You're supposed to have a V here. You're supposed to like converge the rays somewhere here and you're supposed to converge the rays somewhere here. It's hard to draw if you don't cheat because it's just hard. But if you cheat, it's much easier to draw. Okay, everyone. Please make sure you have it in your head, guys. Okay. We're gonna stop here. We're gonna stop. We're gonna stop here today. Right. I'll send a recording for you guys. If you want to do the notes or whatever, guys. I can send you the recording. Request it from me, right? And then we'll continue this on Tuesday night, guys. It's Tuesday night, right? It'll be 8 to 9:30. 8 to 9:30 Tuesday. Just this month now. Just this month. Then next month onwards, you'll all be back to Saturday. Okay. Okay. Okay, guys. I'll see you all next week. Okay. We'll continue this on Tuesday night. Okay, bye-bye.
Sit down,